All right, today we're going to start with lesson 5a. We're going to do some legwork for lesson 6. If you go back in your notes, one page in your paper notes, which is where all of you are, we're going to talk about this idea of conjunction and disjunction. Has anyone seen any notation like this before? Yes? This is called set notation. There's a whole class you can take in college called discrete math, and the discrete math is the logic of math symbols, and this is an example of something you would see. We're going to define a set as set A and set B, and we're going to include in them different people. Okay? So here is set A, here is set B. Now, when we talk about the people or terms of the set, person number 2 is the same as person number 2 here. So in like a real world setting, you could think of it like maybe you belong to the farm club and you're also in choir. You are the same person, but you have 2 different places that you belong. Right? So we're going to talk about 2 notations, one of which you've already used. You've used this one before. We use that in interval notation. It's a symbol for union, but what it really means is the word or. Then we have over here our symbol that looks like an upside down U. That stands for the word and I kind of feel like that reminds me of the way I would make a capital A. So that's what makes me think of the word and when I see it. By definition, it needs to be in both sets. So a conjunction is going to be your and, a disjunction is going to be your or. In math, these 2 words, and or, are very tricky. They don't follow exactly to the way that you use and or in the English language. Let me give you an example of that. If I ask you who is in A and B, I don't mean that it's every single person up here. When I say that, I want to know the overlap. Okay? So I'm looking for the overlap candidates. Who is in both A and B? What would you tell me the answer is? 2, 4, 7. Anybody else? That's it. So A and B as a set would be this data set, 2, 4, and 7. Then we move to or. The overlap is no longer the only solution. This is going to be everyone with no repeats. So who would everyone be? 2, 3, 4, 5, 7, 8, and 9. And is overlap, or is everybody, including the overlap. All right, so let's see if you get it. I've given you 2 number sets from -6 to 8 and from -4 to 12. These are in interval notation. I want you to tell me the overlap of these 2 number sets. And over here, I want you to tell me the or disjunction of the 2 number sets. Go ahead and try that now. All right, today's lesson on arithmetic combinations, you need to use a little bit of vocabulary. The root word of arithmetic is arithmetic. Arithmetic is the first kind of math that you've learned how to do. It involves adding, subtracting, multiplying, and dividing of numbers. The difference is we are now going to add, subtract, multiply, and divide functions. Okay? So it's a whole lot of nuts and bolts and algebra skills. Right? It's not so much thinking, it's more of just practicing and doing the same thing over and over. Next thing, we've got a bunch of notation. I believe in your notes you need to fill these in. So you have the adding of 2 functions, subtracting, multiplying, and dividing. Disclaimer, this is not distributive property. I am not taking f times the x. These are definitions. Okay, so please write these down. Fill them in. also, if you have any highlighters, it would be a great time to pull those out. We're going to do something a little later with notation that will help you to have highlighters. Borrow a neighbor or pen if you have a colored pen. That'll work. Or if you have every color of Sharpie on the planet, you could also utilize those. Now, in terms of your definition, the only one I really want to highlight is the division problem. If I take a function and divide by a second function, why do we now have this disclaimer here about 0? Seems like a lot of extra work. Is it really necessary? Right? And what do we know about fractions? Exactly. When we set up a division problem, fractions are just a visual expression of division. Well, we know fractions, the denominators can never take on 0. You can't divide by 0. That's why they are telling us that whatever function we plug in, we can never allow that function to equal 0, whatever it is. So let's do a couple of these. We're going to skip over domain right now. We're going to come back to that tomorrow. And these are the notes that you have at the bottom. Here's your highlighter part, or pencil, okay? We're going to define f of x. We are going to define g of x. Okay? This is the f function. This is the g function. That's the name of them. When we come down here, we're asked to find 4 different things. F plus g, f minus g, f times g, f divided by g. All this is a game of substitution. F plus g of x means take the orange function and add it to the purple function. So it looks like the square root of 4 minus x squared plus x plus 1. Now notice that when I bring down the g function, I offset it in parentheses. If you don't, you will make sign mistakes. What do you mean sign mistakes? Well, this I can't take any further because I can't combine like terms with the root. But there will be problems when f of x is not a square root that you will be able to simplify further. If I look at f minus g of x, it's very similar. The square root of 4 minus x squared. But now I'm going to subtract x plus 1. Here's the typical sign mistake. If I don't put the parentheses, I don't ever switch the sign of the 1. So my final answer that I would be looking for here is the square root of 4 minus x squared minus x minus 1. Now I have to ask the question, I've been doing this a long time, is there anybody that says, Mrs. Gomer, why isn't that just 2 minus x? It's a square root. 4 is squared, perfect square, x is a perfect square. Does that sound like that would be correct? Yes? Here's my question. What does 4 minus x squared factor into? Two minus x, 2 plus x. Are they the same factor that I could take one out because I have an identical pair? No. Okay, so this cannot be further simplified because I can't factor it and get a quantity which can be removed because they are identical. All right, f times g, same thing. I'm going to take the f function, which is going to be, in this case, my root, and I'm going to multiply it by x plus 1. Right? I'm going to offset this in parentheses. If it was a quantity or an expression, I would want to FOIL that and simplify. F divided by g, no problem. F function, 4 minus x squared, divided by x plus 1, where x cannot equal what value? X cannot be negative 1. If I plug in a negative 1, it violates the denominator. Questions on that? Nothing about domain. Your homework, we are excluding domain for right now. Okay, flip page. second type of functions we're going to talk about today are called composite functions. All right? Composite functions have their root word coming from composition. Where have you heard the word composition before? Probably 3 different places. A book? Yep, composition, like a composition book. What else? Jordan. Science class. What is the composition of a rock? Right? What's it made up of in terms of its elements? Composition. Third one. Come on, music people. Composition in music?
Yeah.
Oh, this is first block. Nobody here's in the band. Anybody in orchestra?
I usually play choir.
Okay. So you've heard of a composition then, correct?
Yes.
Yes? It's a musical piece of
Yeah, piece of music.
music, right? Somebody wrote it, they composed it. Okay. All of those are coming from the idea of made up of. Well, we're going to have that with functions as well. Right? Here's our definition. You have this in your notes. F of G, this is not an O. That is a symbol. It's a perfect circle, very small. Looks like a multiplication symbol that is not filled in. F of G is going to be written as F parenthesis made up of G of X. So now, I'm going to talk about the F function made up of G of X. F is the name of my function. G of X is going to be what I call, I could spell, my ingredient function. It's the function that's going to get fed into the F function. Also, if you would put this in quotes, this is known as my inner function. Makes sense that it's inner because it's inside of F. So these are all different ways I'm going to ask you questions until it sticks in your head when we're dealing with composite functions. All right, we're going to skip over domain for right now, and we're going to go right to example 3. Again, I'm going to have my, sorry about that, I'm going to have my G function here, and I'm going to have my F function here. Step number 1, read what it says. I want F of G. So I want to figure out my F function made up of my G function. What is my G function? G of X is known as what? Square root of X. This now has become exactly like the problems you've seen before. I am going to go to my F function, and every place I have an X, I'm going to replace it with what? Square root of X. So as I come across and read, this is going to be the square root of X. There's my substitution. Squared minus 16. And then I just simplify and I get X minus 16. Did I go too fast or are we good? Okay, so now let's talk about highlighter. Let's talk about where you can highlight that this might help you. Okay? What I would do is I would highlight G of X. I would highlight square root of X. And I would highlight root X here. Okay? Because the ingredient is going to be the part that you have to feed in. You have to know where to take that ingredient and put it into the correct function. So what I wrote in red is what I would be highlighting if you're just using pencil or pen with straightforward notes. All right, next one. Same exact problem. Okay, so I'm going to get rid of this. Now they've reversed the letters on me. Now I want to find G made up of f of x. F of x is my ingredient. What is f of x defined as? X squared minus 16. That quantity is what I'm going to feed into G. So I'm going to go to my G function. Every place I have an x, I'm going to replace it with what? X squared minus 16, the quantity. Does that simplify to x minus 4? Can I make this x minus 4? No, it's just like the one we spoke about earlier. This factors into x minus 4, x plus 4. I don't have the same quantity, therefore I can't reduce the root. That's as far as I can go. So if I want to make a general statement at the end, I can say that g of f of x is equal to the square root of x squared minus 16. Yes.
Will it always be like that for square roots?
That what I give you doesn't reduce?
Yeah. Will we always
I'm going to say 95% of the time. What if I gave you one that maybe this was just f of x equals x squared? When I plugged x squared in, that would reduce because it's not a quantity. Questions? All right. Here's where, in my experience, things start to get a little bit weird for some of you. As long as the problems look exactly the same as this, you're very comfortable. But now look at the next example that I asked you to find. Looks completely different, doesn't it? Yes? But the thought process and what we're doing in terms of an ingredient is the same. So I need you to start to really kind of get on board with this linear thinking of what we're doing. It's just what we do in each step as we go down that changes. So the function of plugging in and finding answers isn't any different. Let me explain what I mean. A lot of words. Okay, if I take a look up here, I've got my two functions, same exact functions, correct? I have f of x and I have g of x. Okay, now I want to find f made up of g of 2. Okay, well, where do I find what g of 2 is? Like, that's something we did 2 lessons ago. How do I determine g of 2? Go to the g function and plug in 2. So I go to the g function, I plug in 2, what do I get? The square root of 2. So g of 2 is root 2. So this gets replaced with the root 2. And now what? Now I go to my f function. Every place I have an x, what do I replace it with? Square root of 2. So I've got square root of 2 squared minus 16. That looks like pretty much math simplification. Root 2 squared is 2 minus 16, negative 14. That's the answer I'm looking for. Thought process. Numbers in for the ingredient, numbers out. Quantities in, quantities out. They should match. Questions? Yes?
Would that be a
Nope, the square root of 2 squared is just plus 2.
Well, would you do square root of 2 times square root of 2 equals square root of 4?
Which is? Okay, good question. This is a really good SAT question, actually. All right, so we're taking 1 second break to answer his thought process, which some of you may have. If you were asked to evaluate, okay, and I ask you what is the square root of 16 in general, just in general, any day of the week, like what's 1 plus 2? 3. What's the square root of 16? The answer is always going to be positive 4, one solution. The only time that, and this is where this is a little confusing, if I ask you to solve and say the x squared is equal to 16, when you take the square root of both sides, you have to include the plus or minus because you don't know if this is positive 4 or negative 4. You're using the root to determine the possible solution, but you have to consider the second because you're talking about something squared. This is not something squared. This is just a simplification of that. Okay? So good question. We good? All right. Nuts and bolts. This is what I'm talking about. Having the same process. Take a look at example 4. What? This looks ridiculously hard. Pull out your highlighters. This is a good time for that. Here we go. Wait a second. I only have one function. Where's the other one that I have to plug in? Well, no problem. Here we go. Here's your red function. Your green function is going to be the same thing. F of x is equal to x plus 3. This is the one I would highlight, the green one. Highlight the green one. So according to this, I want to go to the f function, and I want to plug in the green function. Doesn't matter that I'm using the same one. The process is the same. What is the value of f of x? X plus 3. X plus 3 is the quantity that I'm now going to put into the f function. So I go to my red function up here. Every place I have an x, what do I replace it with? X plus 3. So this x is going to come out, and in its place I'm going to put in x plus 3, but then I still have a plus 3 of the red function to add. So my final answer is x plus 6. Yes? No. We're going to have two component parts of this. The first is the nuts and bolts of the substitution. The second place you can make errors is going to be in the algebra simplification. This is what the prerequisite unit was geared to try to take away those errors from, this part over here. This is the new review content. You had this in Alg 2.